We started this unit talking about parallelograms, about polygons. And then we went from polygons and we got a little more specific. So a polygon was just a closed figure, has at least 3 sides, has a closed figure. Then we went more specifically to quadrilaterals. And then we just kind of in general spent some time talking about the interior and the exterior angles of all polygons in general. Today we're going to focus more on more quadrilaterals, and in fact for the rest of this unit we'll talk more about specific quadrilaterals, which are 4-sided figures. So today we're going to talk about, we're going to focus on parallelograms. So what does it take to be a parallelogram? To be a parallelogram, these are all of the qualities that are going to happen for parallelograms. 1, opposite sides are going to be parallel. So AB is going to be parallel to CD, and AD is going to be parallel to BC. Remember that your little arrows mean that your sides are parallel. So both pairs of opposite sides are going to be parallel. Not only that, but both pairs of opposite sides are going to be congruent. Remember that marking is a little bit different. It's those hash marks. I just put them kind of out of the way so they're not in the way of the parallel markings. But both of your pairs of opposite sides are going to be congruent. All right, so then another thing that happens is that your opposite angles are going to be congruent. So angle D is going to be congruent to all of angle B, and angle A is going to be congruent to all of angle C. Now you back up. One of the things that I want to point out about these parallel, opposite sides being parallel, is you see all these Z's in here. We've got that set. We've also got this set here. And then we've got all these other ones too that go in this direction. So then we can also go this way. So what we're going to end up with is a lot of alternate interior angles. And those are going to be important later when we're talking about them. So don't forget, all the things that go with parallel lines happen because these are parallel. And one of those things is that consecutive angles are supplementary. And so these angles here, angle A and angle D, are supplementary. At the same time, angle A and angle B are supplementary, and you can pair them up all the way around. That happens because the opposite sides are parallel. And then the last thing that happens is that your diagonals bisect each other. Now, make a note. That doesn't mean that they're equal to each other. DB, okay, DB, which is this diagonal right here, is not equal to AC. That's not what this is saying. What this is saying is that DB cuts AE in half, and AC cuts DB in half. And so these pieces are equal to each other. That's what the diagonals bisect each other. They cut each other in half, but they're not equal to each other. Other things have to happen for those diagonals to be congruent. The other thing that you can, one way that you can tell that a quadrilateral is a parallelogram, if you don't have both pairs are parallel or both pairs are congruent, what you can have is that one pair of opposite sides is both congruent and parallel. So say I don't know anything about these two sides, AD and BC, but I know that AB is parallel and congruent to CD, then I would be able to say that this is a parallelogram also. So you either have to know 2 things about one pair of sides or one thing about 2 pairs of sides. So let's use those properties then to solve some of these problems. So if AC, and you always need to start these problems by labeling your pictures, because then it's going to tell you how to work the problem, how you need to set it up. So AC is 8x minus 14. EC is 2x plus 11. So this is going to obviously use that the diagonals have been bisected. So I have the whole diagonal and I have half the diagonal. So the important part about this is recognizing that that 2x plus 11 can be duplicated because that diagonal has been cut in half. And so now we can say that 8x minus 14 is equal to 2x plus 11. So that's 4x plus 22. I doubled it up. And then we just do the algebra and solve it, and we get that x is equal to 9. So in that one, we were using that the diagonals were bisected. but you've got to label it so that you can see what you're talking about. And this is, you needed 2 parts to set it equal to your whole. Number 2, I have angle Q and I have angle T. Well, I know that Q and S are congruent, R and T are congruent, but because I know that the lines are parallel, what I know is that those consecutive angles are supplementary. So that means 3x plus 5. That means angle Q plus angle T has to equal 180 degrees because consecutive angles are supplementary because the lines are parallel. So if that's the case, then I have 3x plus 5 plus 9x minus 17. That is 12x minus 12, and I know that that has to equal 180. When you go through the algebra, you get that x is equal to 16. You should know how to do the algebra at this point, so I just want to focus on the geometry side of it. So this one's a little more tricky. If the the measures of the angles BCD is 51 degrees. So BCD, remember if you trace from B to C to D, it's talking about this entire angle right here is 51 degrees. 51 degrees. I want to solve for x. And so pretty much anytime you're going to have these diagonals and you're talking about the angles, you are more than likely going to be using that the alternate interior angles are congruent. So what I want to do is I'm going to pull, and if you ever have numbers, go ahead and label them all. So this is 51 degrees, or excuse me, not 51, it's 55 degrees because it's alternate interior. I do know that this angle is 51 degrees. So whichever way that you can see it best, but what we want to see is this. Those consecutive interior angles add up to 180 degrees. So now that I've got that 55 labeled and that 51 labeled, it's easy for me to see now how all of those angles together add up to 180. So I take 14x plus 4 plus 51 plus 55, and those are supplementary. Because those lines are parallel, consecutive interior angles are supplementary. When you do the algebra, you go through and you get that x is equal to 5. So you want to remember, anytime you've got a diagonal and you're talking about the angles, most of the time you're going to be using those alternate interior angles. Not always, but it is always a possibility when you see that crisscross. Always kind of look for, this is a good hint, always look for this kind of Z situation going on right there. If the measure of angle VST, so V to S to T, that's this angle right here, it is 5x plus 23. And the measure of angle VUT is right here, it is 8x minus 49. Now I've got those diagonals, but right now I don't need them because what I do know is that opposite angles are congruent. Okay, when it's a parallelogram, the opposite angles are congruent. Of course, we're assuming all of these are parallelograms. So I set them equal. 5x plus 23 is equal to 8x minus 49. And again, always label your picture. I know it takes a little bit of time, but it makes it so much easier to see what's going on. So you do your algebra, you go through, and you get that x is 24. Now, the question that I asked, though, was for how big is SVT. So SVT is this little angle right here. And I know that your inclination is going to want to be that it's 20 degrees, that's been bisected. And that is not the case. It has to have more properties for that to happen. So in a parallelogram, the angles are not bisected. The diagonals are bisected, but not the angles. But what I do know is I can find out how big this whole angle is right here by substituting in the 24. So what I find out is that that is 143 degrees. Well, I know then that I have my consecutive interior angles, and I have this piece, and I have this piece, and I just need that yellow piece now. So I can take 143 and add 20 to it, and I get 163, and I know they're consecutive interior angles, so if I subtract 163 from 180, then I get that angle is 17 degrees. You just really have to label it and pay attention to how everything is labeled because it just helps define how these problems are going to work. So we've got parallelogram DCBA. Notice that as we go around the parallelogram, we don't start over, we pick a starting point and then we walk, quote unquote, we walk around the shape. It's not D, C, B, A like that. That's not what we do. We always walk around the shape when we name it. Just side note. So if we have DC's 36, DA is 4x minus y, AB is 2x plus y, and BC is 24. So what I know is I've labeled my sides, and I know that my opposite sides are congruent. So I'm going to go ahead and set up what I have. 4x minus y equals 24. Instantly, I notice that I have two variables. But the good thing is since I have two variables, I also have two equations. So if I look at this, I notice that my y values are already equal in value. They both are equal to 1, and they have opposite sign. One is positive, one is negative. So that makes it nice when I add those two equations together. Those are going to cancel out. They're going to eliminate. This is a system of equations. So 4x plus 2x is 6x. 24 plus 36 is 60. And so I get x is equal to 10. Now, sometimes you might have to multiply something to make one of the variables go away, but that's our goal, is to eliminate one of the variables. So if x is 10, I'm just going to go back up. It doesn't matter which equation you use. But when I did it earlier, I used 2x plus y equals 36. Now we know that x is 10. Plug it in, subtract 20 from both sides, and you get that y is 16. Now, before you start trying to figure out this problem, go ahead and label everything so that you can see. So angle 1 is 3x, angle 2 is 4x, and angle 3 is x squared minus 70. And so what I notice, again, I've got these diagonals, I've got angles. And so what I notice is this right here. I've got these alternate interior angles. And so that's how we're going to know how to set this up. So I've got 3x is equal to x squared minus 70. This is a factoring problem. I can tell because of that x squared. And so that means I have to set it equal to 0. So I'm going to subtract 3x from both sides. So I have x squared minus 3x minus 70 equals 0. I always write it so that it's in that order, x squared, x constant, so that it's easy to factor. Now, if you want to do your x factor or however you want to do it, but I think that it's easier since there's a coefficient of 1 right here, find the factors that multiply together to give you 70, that add together to give you negative 3. So I know my first and first give me x squared. My last times last would give me 70. I need it to be a negative 70, and I need the 3 to be negative. So I'm going to make the 10 be negative and the 7 be positive. If you're still struggling with factoring, then we need to talk. Once you get this, then we set each one equal to 0. X minus 10 equals to 0. So you add 10 to both sides, and we get x is equal to 10. I'm going to write it over here because I don't know if it's the answer yet. And then x plus 7 equals to 0. Subtract 7 from both sides, and we get that x is equal to negative 7. We need to test both of them. So if I plug in 10, I get 30 and 40 and 30, so that works. But if I plug in negative 7, then I get negative 21 and negative 28. I can't have angles that are negatives, so I throw out the negative, not because it's negative, because sometimes they work, but because it doesn't work when I plug it back in, so be careful with that. So x is 10. And the measure of CED. So CED is this whole angle right here. Well, if angle 3 is 30, then that means angle 2 is 40, then that would be 30 plus 40, which is 70, because these are alternate interior angles also. So then these two angles have to be congruent. So you do have to go back and remember some things about alternate interior angles. So the director of a marching band uses a coordinate plane to plan the band's shows. If you've ever watched the A&M Fighting Texas Aggie Marching Band, you can see that this would be really helpful for their band director as they're laying out their plans for their marching shows during halftime. So the 4 tuba players will form a parallelogram at J, K, L, and M. What are the coordinates of the 4th tuba player? And so we need to use the qualities that we know, and we're going to go back and kind of use some little shortcuts too. So I know that it's going to go down here somewhere. I know that the other tuba player is going to be in that blue area somewhere. So I want to do this. I want to mark JK. So one of the things, remember, it needs to be parallel. It also needs to be equal in length. We can do that with kind of kill two birds with one stone, so to speak, in that if you look at your slope, you go up 1 to the right, 1, 2, 3, 4, up 1 over 4. If I mimic that from L, because that's going to be the side that's parallel, I can go down 1 and to the left 4, because I want to basically go backwards to where it was. If you draw that in, you see you have the exact same slope. And then you kind of notice too here, if I draw these in, I also have a slope of 1, 2, 3, 4, 1, 2, 3. So a -4 over 3, and then a -4 over 3. So those are parallel. Also, if you think about it, right, think Pythagorean theorem, that'd be 4 and 3 and 4 and 3. Well, then that means Pythagorean theorem is going to give you the same thing. It's the same with the 1 and the 4, is that those lengths have to be the same. Since the two sides of one triangle are congruent to the two sides of the other, the third side has to be congruent because it's a right angle. That's that side angle side. Okay, so then that means that the coordinates of our other tuba player would be at 0, -3. And that would give us the same sides congruent and the same sides parallel. Those are the things that we need to test to tell if it is a parallelogram.